Okay, this is section 3.3, exercise 36. So here we're given a function f of x is equal to x squared minus 2x plus 1 over x plus 1. And we are asked to find the critical numbers. This is more applying the first derivative test. So I'm supposed to find the critical numbers. Well, I need f prime of x, which is going to be a little ugly because of the quotient rule. So the derivative of the bottom is 1. That's not so bad. And then times the thing on the... Oops, what did I just say? See, I can misspeak myself. Sorry about that. Try that again. Derivative of the top, which is 2x minus 2, all times the thing on the bottom, then minus the derivative of the bottom, which is 1, times the thing on the top, so that's x squared minus 2x plus 1, all divided by x plus 1 quantity squared. So there, I thankfully got that right that time. Now this is the 2x minus 2. That's really just 2 times x minus 1, and I know that x minus 1 times x plus 1 is x squared minus 1. So I'll get a 2x squared minus 2 for that first term. And then the second term is fine. I just need to remember that negative is on everything. So I'll get a minus x squared and a plus 2x and a minus 1. All over x plus 1 squared. So let's see, I've got a 2x squared minus an x squared, so I get x squared plus 2x, and it looks like minus 3 over x plus 1 squared. So now, as I look for critical points, one critical point will be from the numerator being 0, or 1 or 2 critical points. We'll see what we have there. And then another critical point would come from the denominator being 0. It would be undefined there. So let's set it equal to 0 first. F prime of x equal x squared plus 2x minus 3 over x plus 1 squared equals 0. Well, again, I just multiply everything by the denominator and that goes away. I just am curious about the numerator, and I have I think x plus 3 and times x minus 1. So I end up with x being negative 3 or x being 1. So there's a couple critical numbers. But then also f prime of x is undefined at x equal negative 1. Now actually, I could toss in f of x and x, f prime. So really, I would call x equal negative 1 a 0 order critical point. But it is a critical point, or a critical number. And then we have where the derivative is 0 there. So we've got those 3 critical numbers. Okay, so critical numbers are negative 1, negative 3, and 1. Okay, so we have that. Oops. All right, so that was part A. I found the critical numbers. Now I need to look for intervals of increasing and decreasing. And again, I just go with all my critical numbers. So here's negative 3, there's negative 1, there's 1. And I'm going to look at f prime in each of these intervals to figure out whether it's positive or negative. So I'll start with like f prime of -4. Okay, f prime of -4. Now, what I know is the denominator is squared, so that's never a problem. Yeah, it's always positive. So I really am only interested in the x plus 3 times x minus 1. So, so I've got a -4 plus 3 times a -4 minus 1, and then all over something squared. And so that's negative, so this is greater than 0. Okay, so in here, f prime is greater than 0. Now let's try f prime of -2. Well, same sort of thing. I have the -2 plus 3 times -2 minus 1, and over something squared. That is positive, the other part's negative, so this is less than 0. Okay, so I come back up here and this is less than 0, so it's, this is positive, this is negative. Now I'll look at 0, f prime at 0. I get 0 plus 3 and a 0 minus 1 all over something squared, and so that is also negative. And so this is also negative here. And then finally look at 2, I guess, f prime at 2. And I have 2 plus 3 times 2 minus 1 over something squared, and both the terms in the top are positive, so that's positive. And so this is greater than 0 and a plus. So as I look at for relative max and min and so forth, what I need to do is I'll kind of redraw this again. See, so we had a -3, a -1, a 1, like that, and we were, what was it, a plus, minus, minus, plus. So we were a plus, a minus, and a minus, and a plus. And so we had a positive slope, and then we had a negative slope. Then we had a negative slope, and then we had a positive slope. Okay, so there's a max, there's a min, and here, now, I know this is neither, actually, oops, neither? How about neither? Now, one reason I know it's neither is simply looking at the theorem type of thing, in that, this is negative, that's negative slope, and so it's decreasing on both of those, so that would not be a relative max or min, or it wouldn't be a relative extrema. But more importantly, remember here f and f prime are undefined. So even if this had, say, been decreasing and then the next one increasing, I would not have had a relative max or min, because the function itself is just undefined. Okay, so there are my, so I have a relative max at x equal -3 and a relative min at x equal 1. Okay, and then D is that I go and check. So here we go. And so if you look, whoops, I can't get that pen too close there. It does weird stuff. Whoa, I'm not sure what just happened. Whoa, man, this is not the greatest. I may have to switch my technique here for working on these things. Oh, those are negative numbers. No wonder it's doing weird things. Okay. Phew. Okay, now we're getting... Sorry about that. So we can see by the gray points there that, you know, that is at -3, and that is a relative max. That is at 1, and it is a relative min, and the function has a vertical asymptote actually at x equal -1. And we look at the derivatives. The function's increasing to the left of -3. We can see that better if I kind of pull this up. So increasing at the left, then decreasing, and then we jump to this other curve, and it's decreasing still, and then increasing. So it went positive, negative, negative, positive, just like we found. So there we go. There is exercise 36.